Numericals on relative velocity. Let us take a question. A man moving with 5 meters per second observes rain falling vertically at the rate of 10 meters per second. Find the speed and direction of the rain with respect to the ground. Now the sum goes like this. Here is a man he is walking in rain with a speed of 5 meters per second. Now the rain appears to fall vertically. It appears to fall vertically. Now the rain appears to fall vertically. It appears to fall vertically on him. The rain appears to fall vertically at the rate of 10 meters per second. So velocity of rain with respect to the man is 10 meters per second vertically. The man is moving with a speed of 5. Now question is, you have to find the speed and direction of the rain with respect to the ground. Now, velocity of the rain with respect to the man is vertically downwards and it is 10. it is 10 meter per second. The man is moving with a speed of 5 meter per second in this direction. This is the velocity of the man with respect to the ground, which is 5 meter per second. Now we had the equation velocity of, now we want velocity of rain with respect to ground. Now in the first video we have understood, suppose rain is my P, S is my ground, and S dash is my man. So here P is my rain, S dash is man who is moving frame, and S is my ground. So what can we write? P is my rain, S is my ground. So velocity of rain with respect to ground is equal to, here P is my rain, S dash is my man, velocity of rain with respect to man plus S dash is my man and S is my ground, velocity of man with respect to ground. So if you add velocity of rain with respect to man and velocity of man with respect to ground, you get the velocity of rain with respect to ground. See, the first and the last comes. You can memorize the formula in this way. The first and the last comes. In between it is the same. So if I add this two, I will get the velocity of the rain with respect to the ground which I want. So this is my, from the triangle of vector addition, this is my velocity of rain with respect to ground. This is 90 degree. So VRG square can be written as 10 square plus 5 square. That is 100 plus 25. This is 125. So VR rain with respect to ground, the magnitude is 5 root 5 meter per second. So we have found the speed. Now we have to find the direction, in which direction the rain is falling. Let this angle be theta. You have to find in which direction it is falling. So you can say tan theta is perpendicular by base. So it is half. So theta can be written as tan inverse half. This is the direction. So what happens? Actually, rain is falling in this direction. And the man is moving in this direction. To the man, the rain appears to fall vertically. This is the real direction of the rain with respect to the ground. And the man is moving in this direction. Therefore, the rain appears to come in this direction. Now we can think of the sum in this way. Give the man an equal and opposite velocity 5 meters per second in the opposite direction. The man comes to rest. Now, when you add something to one side of the equation, you have to add the same to the other side also. So what happens? Say this is the velocity which is added to the velocity of the rain. As a result, the rain, this is my resultant rain. So the rain should be falling in this direction. The rain should be falling in this direction. So if this is the velocity of the man, which is 5, and this is the real velocity, so this is my resultant velocity 10. This is my velocity of rain with respect to man, which is vertically. And this is the velocity of the rain with respect to the ground. So velocity of the rain with respect to the ground plus the velocity of the man. This is the velocity of the man, which is 5 meters per second in the reverse direction. So as a result, you see the rain falling vertically. You can do it in any one of the ways. You can do it in this way, or you can bring the man to a state of rest and add the same velocity with the real velocity of the rain, and you can see that it is falling vertically. Or you can use this formula: velocity of rain with respect to ground is velocity of rain with respect to man plus man with respect to ground. So velocity of man with respect to ground was 5 and rain with respect to man was 10. So if you put this value over here, you get the velocity of the rain with respect to the ground. Let us take another question. Two particles A and B are moving with constant velocities v1 and v2 at t equal to 0. v1 makes an angle theta 1 with the line joining A and B, and V2 makes an angle theta 2 with the line joining A and B. Find their relative velocity along the line of approach, or find their velocity of approach. Now the question is in this way: there are two particles A and B. Initially, A has a velocity v1 at an angle theta 1, and B has a velocity v2 at an angle theta 2. We are asked to find their relative velocity of approach. Now, velocity of this can be broken into two components, one in this direction and one in this direction. This is v1 cos theta 1. This is v1 sin theta 1. This v2 can be broken into two components. This is v2 sin theta 2 and this is v2 cos theta 2. Now their relative velocity of approach, we have to take the two cos components. Now we can bring one to a state of rest. We can bring one to a state of rest. Let us bring B to a state of rest by giving it an equal and opposite velocity. Giving it v2 cos theta 2. This is v2 cos theta 2 minus. Now when you are adding this, you have to add the same to A also. So when you are adding this to A, this one was v1 cos theta 1. To that we are adding v2 cos theta 2 in this direction. So this one, its own vector was v1 cos theta 1. This is for particle A. And then for B, we are adding v2 cos theta 2. Now B is in a state of rest because I have forcefully brought it to a state of rest. Now relative velocity of A approach, or relative velocity of A with respect to B along the line, this is the velocity of approach along the line joining them, is v1 cos theta 1 plus v2 cos theta 2. So you can do it in any one of the steps. Either you bring one to a state of rest and add the same velocity to the other, or you can use the formula for relative velocity. Now let us go on to the next sum. A child in danger of drowning in a river is being carried downstream by a current that flows uniformly at a speed of 16/3 meter per second. The child is 600 meters from the shore. The child is 600 meters from the shore. And 800 meters downstream, of a helipad, when the rescue helicopter sets out, and the helicopter follows, the same direction throughout the motion. Throughout the motion. If the helicopter proceeds at the maximum speed of 80/3 meters per second with respect to air, and air is blowing with velocity of 4 meters per second perpendicular to the river flow, find number 1, heading at what angle? Heading at what angle with the shore should the helicopter take off? And number 2, calculate the time taken by the helicopter to reach the child. Now here the question is like this. A child is in danger of drowning and it's moving in this direction with the downstream current that flows uniformly at a speed of 16/3 meter per second. The child is 600 meter from the shore. The child is 600 meter from the shore and 800 meter downstream from the helipad. It is 800 meter from the helipad. This is the helicopter, a helipad, and this is 800 meter from the helipad. Now, there is a wind which is flowing perpendicular to the river. This is the flow of the river. Now, wind is flowing at the speed of 4 meter per second perpendicular to the river. So, this is the wind. Which is flowing at 4 meter per second. The question is, at what angle should the helicopter take off? At what angle should the helicopter take off with the shore, and calculate the time taken by the helicopter to reach the child. So here was the child, 600 meter from the shore, 800 meter from the helipad. This was my child. Now the child was flowing due to the river flow in this direction, which was 16 by 3 meter per second. In the question it was given that the helicopter proceeds with maximum speed of 80 by 3 with respect to air in the same direction. The direction of the helicopter should be in this direction. So, if the helicopter now starts moving with a velocity of 80 by 3 in this direction, wind has a velocity of 4 meter per second in this direction, then as a resultant, the helicopter will move in this direction. The resultant velocity will be in this direction. Then the resultant velocity will be in this direction. This is the resultant velocity of the helicopter. Let this angle be theta. The resultant velocity of the helicopter is in this direction. Because in the question it is said that the helicopter should move in the same direction as the child. So, if this angle is theta, then we have to find, now if we break this velocity of the helicopter into two components, then this is 80 by 3 cos theta. This is 80 by 3 sin theta. Now here we can say that we can bring the child to a state of rest by applying an equal and opposite velocity 16 by 3 to the child. We can give the child an equal and opposite velocity 16 by 3. So the child comes to rest. And we have to apply the same velocity to the helicopter also. So this is 16 by 3. So the helicopter now has, in this direction, 80 by 3 cos theta minus 16 by 3. And in the vertical direction it has 80 by 3 sine theta minus 4. So in what angle should it move? If this angle is theta, then tan theta is perpendicular by base, that is 80 by 3 sine theta minus 4 divided by 80 by 3 cos theta minus 16 by 3. Now tan theta is sine theta by cos theta, that is equal to 80 by 3 sine theta minus 4 divided by 80 by 3 cos theta minus 16 by 3. Now if you cross multiply 80 by 3 sine theta cos theta minus 16 by 3 sine theta is equal to 80 by 3 sine theta cos theta minus 4 cos theta. This two term cancels off, minus minus cancels off. So sine theta by cos theta, this 4 and 16 cancels off, is 3 by 4. Or tan theta is 3 by 4. So theta comes out to be 37 degree. Theta comes out to be 37 degree. Now the question was, calculate the time taken by the helicopter to reach the child. The horizontal velocity of the helicopter is 80 by 3 cos theta minus 16 by 3. Theta is 37 degree. 80 by 3 cos 37 degree minus 16 by 3, which comes out to be 16 meter per second. Now according to our sum, now the child is at rest and the horizontal velocity of the helicopter is 16. The distance between the helipad and the horizontal distance is 800 meter. So the time taken to reach the child is 800 meter by 16. That is equal to 50 seconds. So let us come back to the sum once again. A child was drowning. The current was moving the child with a speed of 16/3. Wind was coming in the vertical direction. The question was, in what angle should the helicopter take off so that it goes in the same direction of the child and rescues the child? Now, if the helicopter has a velocity, it moves it with the angle theta, then the resultant velocity in this direction should be 80/3 cos theta minus 16/3. And this direction, the velocity should be 80/3 sin theta minus 4. Then the angle theta can be obtained by tan theta is perpendicular by base. So theta came out to be 37 degree. So if it goes at an angle of 37 degree, then the sum is reduced to the child is at rest. It is going at an angle of 37 degree. It has a forward velocity of 16. It has a forward velocity of 16. So what time will it catch the child? 800/16, that is 50 seconds. Now let us take another question. A man is standing on a road and observes that rain is falling at an angle of 45 degree with the vertical. The man starts running on the road. With constant acceleration of 0.5 meter per second square. After a certain time, from the start, of the motion, it appears to him that rain is still falling at an angle of 45 degree with the vertical, with speed of 2√2 meter per second. Motion of the man is in the same vertical plane in which the rain is falling. We have to find The speed of the man, find the speed of the man when he finds rain to be falling at angle of 45 degree with the vertical. Now, initially the man was here. This is the initial position of the man. Rain was falling. At an angle of 45 degree. It was falling at an angle of 45 degree with the vertical. This is the velocity of the rain with respect to the ground. Rain, according to the sum, rain is falling at an angle of 45 degree with the vertical. So rain is falling at an angle of 45 degree with the vertical over the man. So this is the velocity of the rain with respect to the ground, which is falling at an angle of 45 degree with the ground. Now what happens? The man starts running. This is the final position of the man. Here again, the man sees it falling at an angle of 45 degree with the vertical. So it must be falling in this direction. Again, it is seen that now the rain is falling at an angle of 45 degree with the vertical. That means now the rain is falling in this direction. The velocity of the man, this is the velocity of the man with respect to the ground. Now we know velocity of rain with respect to ground is velocity of rain with respect to man plus velocity of man with respect to ground. So this can be written as, from here, velocity of rain with respect to man is equal to velocity of rain with respect to ground minus velocity of man with respect to ground. So if we draw the figure now, say this is the velocity of the man. Velocity of the man is moving in this direction. This is the velocity of the man with respect to ground, moving in the forward direction. This will be minus Vmt. Now velocity of rain, if the velocity of the rain with respect to the ground is in this direction, then the resultant is velocity of rain with respect to man, because velocity of rain with respect to man is velocity of rain with respect to ground plus minus vmg. This was the velocity of the man. This was the velocity of the rain. Now velocity of rain with respect to man is velocity of rain with respect to ground plus negative velocity of man. Now when you plus this is the resultant this. So this is the velocity of the rain with respect to man. Now if I break this into components, now this angle is said to be 45 degree. Now this plus this is this. That means if I break up this into components, this is velocity of rain with respect to man cos 45, and this arises due to the vertical component of this, because this velocity vector will not have any vertical component. So this vertical component is due to this velocity vector. So this is equal to velocity of rain with respect to ground cos 45. Cos 45 cancels. Now velocity of rain with respect to the man is given as 2 root 2. So that will be the velocity of the rain with respect to the ground. That will be the velocity of the rain with respect to the ground. Now, once again, if we go back to the original equation, velocity of man with respect to ground we have to find out. Velocity of man with respect to ground is velocity of rain with respect to ground minus velocity of rain with respect to man. This is coming from the first equation. Now I have to find out velocity of man with respect to ground. So it is the addition of VRG, which is this vector, plus minus of VRM. So if we draw the figure once again, this was VRG. This was VRG. And this was VRM, making an angle of 45 degree with the vertical. It was making an angle of 45 degree with the vertical. Now I have to add VRG and minus VRM. Now when you do minus VRM, it is equal and opposite. This is minus VRM. Adding these two velocities, I will get the velocity of the man. Now when you add these two velocities, I can break this into two components. One in this direction, one in this direction. Similarly, I can break VRG into two components. One in this direction and one in this direction. Now VRG and VRM both are equal to 2 root 2. We have got both are equal to 2 root 2. And all these angles are 45. Addition of this velocity and this velocity will give the velocity of the man, because it is minus VRM. Now when you add this vector and this vector, these two components cancel each other, because this is 45, this is 2 root 2, so this is 2 root 2 cos 45, and this is also 2 root 2 cos 45. So these two vectors will cancel, and in this direction these two vectors will add up. So it is 2 root 2 sine 45. This angle is also 45 plus 2 root 2 sine 45. So this is the velocity of the man with respect to ground. So this is 2 root 2 into 1 by root 2 plus 2 root 2 into 1 by root 2. So velocity of the man with respect to the ground is 4. The answer is 4. So if we come back to the original sum, initially rain was falling at an angle of 45 degree and the man starts running, and after some time again the rain appears to fall at an angle of 45 degree. You are asked to find out this velocity. Now we know velocity of rain with respect to ground is velocity of rain with respect to man plus man with respect to ground. Rg should be at the end. This is a basic equation. From this equation you can find out any one. Now first what we are doing, we are finding out velocity of rain with respect to man. This is VRG minus VMG. Just take it the other side. That means this is the addition of VRG vector plus negative vector of VMG. Now this is VMG. Negative vector VMG will be the opposite direction. So this vector VRG is this one. VRG plus negative vector will give you the velocity of rain with respect to man. Now this is broken into two components and this is also broken into two components. Now this vertical component can only come due to this, because when you break this into components and this has no vertical component, so vertical component of this comes only due to this. This vector and this vector will give us this vector. And if you break this into components, this vertical component will give the vertical component of this, because this is a horizontal vector. It will not contribute to the vertical component. So from here we found out VRG cos 45 is VRM cos 45. Their vertical components are same. Velocity of rain with respect to man is given as 2 root 2. It is given in the sum. So we find out velocity of rain with respect to ground. Now we come back to the original equation. We have to find out VMG. We have to find out VMG. This is VRG minus VRM. This is VRG vector plus minus VRM vector. Now VRG vector was this. VRM vector was this. You have to do minus VRM, means in the opposite direction this is minus VRM. Now you have to add this vector and this vector. These two vectors we have to add to get the velocity of the man. Both the vectors are broken into components. These vertical components cancel each other. Horizontal components add up, and that will give the velocity of the man, which is 4 meters per second.